have a question here related to intertemporal choices. Please go through this once before starting this one. So they have given utility function and his budget constraint, and they asked optimal demands C1, C0 and C1. Here time periods are T0 and T1. Okay, and they are asking us to find C0 star and C1 star in first question, and next question they are asking about how they are related to interest rate, and it's basically comparative statistics they are asking about. And third question is they are asking about the relation between W and R, in which case when C1 equals to C2, here sorry it's not C1 equals to C2 here, in this case it is C0 star equals to C1 star. Okay, let's start solving this question. Now to solve this question, the best method is Lagrange. So we'll form a Lagrange, but before that we should write that budget constraint is C0 plus C1 divided by 1 plus R equals to W, and utility is log C0 plus delta log C1. Here what is delta? Delta is discounting factor, as we studied in the last video. What does it make? It provides the utility in such a way that if it's less than 1, he is getting the utility from C1 a bit, or like depending upon this delta, obviously less than what he is spending at time T2 or consuming second period here, first period consumption when he is presently in this case. Now the wealth he has is only W. It's not changing in this case. It's not like W1, W0 plus W1. He's not earning anything other than this, which case this wealth that's present in 0 period. And they are talking about interest rate, how much he is earning. If he is saving anything, suppose if he has like W is a wealth, in that W minus C0, whatever is remaining. Now on this remaining, yes, he is earning SR. This is another case. Okay, this is what happening, but these extra variables are not necessary for us. So we'll start with the question and we'll form Lagrange. What is Lagrange here? Maximizing utility. That's our goal, right? How we will utilize maximizing utility means, like utility means we are optimizing C0 and C1. So the thing is maximize utility with respect to budget constraint. So what is that utility here? Lagrange is given by log C0 plus delta log C1 minus lambda in the bracket C0 plus C1 divided by 1 plus R minus W. Now delta L by d C0 is 1 by C0 plus 0 minus lambda 1 equals to 0, and here 1 by C0 equals to lambda, take it as 1, delta L divided by delta C1 gives us 0 plus delta divided by C1 minus divided by here C1. This is the term that is going to be derived here, that gives us 1 by 1 plus r equals to 0. So delta divided by c1 equals to lambda divided by 1 plus r. Basically delta 1 plus r divided by c1 is equals to lambda. This is second equation. Now use these equations. How we can use these equations? We can use these equations to find c0 and c1. So lambda, in both cases lambda I can equate first one with second one. 1 by c0 equals to delta 1 plus r divided by c1. So it's nothing but c0 equals to c1 divided by delta 1 plus r. Alright. Now I'll use that budget constraint, that is c0 plus c1 divided by 1 plus r equals to w. So in this, if I add this c0 value, c1 divided by delta 1 plus r plus c1 divided by 1 plus r equals to w, I'll be getting c1 in divided by 1 plus r in the bracket 1 by delta plus 1. Basically this is nothing but 1 plus delta divided by delta equals to w. Okay, so I'll take this term here, I'll take this to left side. Now what is c1? c1 equals to 1 plus r, and this is getting reciprocated into delta divided by plus 1 into w. This is c1. So we got c1. Now this is the consumption of period 1. Now if we use the same value to find c0, so this is c0 I have it as c1 divided by delta into 1 plus r. So c1 is w into delta into 1 plus r divided by delta plus 1. This is c1 divided by the remaining part is this one, that is delta, sorry, guess I made a mistake here, delta into 1 plus r. So this term are getting cancelled, so the value is w divided by delta plus 1. This is c0. So we got solution for first question. Now they are asking about comparative statistics. So what happens to c0 and c1 if r increases? So it's nothing but we are checking this one. What we are checking, what happens to c1 as r increases. As r increases, let's see about c1. So I am integrating this one. So the results will be delta into w 1 plus r divided by delta plus 1. Again, if I differentiate this one once more, I'll be getting 1. So this is what I'm getting, which is obviously more than 0. So if r increases, c1 also increases, or the consumption at time period 1 also increases. Now let's see about c0. Now c0 divided by dr. So c0 is w divided by delta 1. So there is no R in this case, so the answer is 0. So consumption at period 0 is independent of interest rate, right? This is the answer for second question. Now the next question is, we are equating this. It what happens, what is the relation between R and W if C0 equals to C1 star? So what is C0? C0 is W divided by 1 plus delta, which is equals to delta into R, 1 plus R divided by 1 plus delta into W. So in this case what happens, these things get cancelled, so I'm cancelling this one also, so the remaining is 1 equals to delta 1 plus R. So 1 equals to delta plus delta R. So here what are we having now? So there is a relation between interest rate and 1 by delta equals to 1 plus R. Now 1 by delta. So as, or I can say that these two terms are inversely related. So as delta is decreasing or increasing, R decreases. If delta decreases, R increases. This is the relation between R and delta, but R and W are independent of each other. So this is the answer. Thank you.